Department of Vegetable Science, College of Horticulture and Forestry, Pasighat, Arunachal Pradesh. He graduated from the University of Horticultural Science, Bagalkot, Karnataka during 2014. He completed his MSc and PhD in Vegetable Science from IARI New Delhi in 2016 and 21, respectively. Dr. Maragal has qualified National Eligibility Test by ASRB in 2016 as well as in 2021 with 75% and 81% respectively. Before that, he qualified ICAR JRF in horticulture with All India rank 4 in 2014, then in vegetable science with All India rank 3 in 2015. He has also qualified ICAR SRF in vegetable science with All India rank 1 in 2016. Dr. Maragal has strong expertise in vegetable breeding through conventional and molecular approach. He has been honored as a proud alumni of University of Horticultural Science, Bagalkot, for securing All India Rank 4 in ICR JRF 2014. He has received Best Doctoral Research Award for Outstanding Doctoral Research in 2021 from Karnataka State Science and Technology Academy, Bangalore. He also received Dr. G.S. Randhwa Award for Outstanding Doctoral Research in Horticulture in 2023 from IIHR Bangalore. Additionally, he received the NABARD-sponsored Professor B.L. Chopra Gold Medal Award in 2022 from IRI New Delhi and IRI Best Student Award for the year 2022. He has significantly contributions as a principal investigator in projects such as AICRP on vegetable crops funded by IIVR Varanasi and All India Network Research Project on Onion and Garlic, which is funded by Directorate of Onion and Garlic Research, Pune. Dr. Maragal has published 9 research papers in national and international journals and contributed 8 book chapters. Moreover, he is a renowned uh, olericalist for Endeavor. Now I invite Dr. Maragal to deliver his talk. Sir, please.
Thank you so much, sir. Is it audible, sir? Am I audible?
Yes, you are audible.
Thank you, sir. Just a few minutes, sir. I'm sharing my slides. Sir, is it visible?
Yes, sir. Yes, sir.
Sir, my slides are visible, sir.
Oh, slides are not visible, sir, till now. Sir, right now the slides are visible.
Hello. Sir, is it visible now?
Yes, sir, visible. But make it full screen mode, sir.
I'm doing
Slide
that
show.
one, sir. Now, sir.
Please click the below the slideshow mode, sir. Make it
Which one,
entire
sir?
screen. Make it entire screen.
Where is the option that one?
Madam Hamida, are you there? It's okay, sir. It's visible. Just click on the slideshow mode so that it will be displayed
That
in
is
entire screen.
not enabled. So that slideshow, that slideshow is not available here. Slides are not moving, sir, here.
Sir, please stop sharing and share the entire screen, sir. Then that will work.
Now,
Sir,
now it's visible, sir.
Sir, please. The slides are visible, but it is not in slideshow mode. So please stop sharing and again share the entire screen.
Share and okay, I'll try, sir.
Yes, sir. Please.
Now, sir.
Yes, sir. Now it is
Hello.
okay. Okay, sir. Okay. Now it is fine, sir.
Oh,
Yes,
okay,
sir.
okay.
Now it is okay, sir. Fine, sir. You
Yes,
can
sir.
continue, sir.
Oh,
You can
thank you.
start it. Yes.
Thank you, sir. Good morning, everyone. Myself, Dr. Siddharth Margal, Assistant Professor, Department of Vegetable Science, College of Horticulture and Forestry. Today, I am here to deliver a lecture on high-tech vegetable nursery, a new avenue for agri entrepreneurship. As we know, Indians. Means India is the second largest producer of vegetables in the world, followed by China. As per 2024 and 25 estimate, we are producing around 220 million tons of vegetables with an area of 11.40 million hectares, with the annual growth rate of 2 to 3%. It's because of rapid advances in the production technology with respect to whatever the cropping technology, irrigation, weeding, and harvesting. And second one is the replacement of high yielding varieties by hybrids. Suppose at present, almost 25 to 30% of whatever the area is there in India, it's under hybrids. Suppose you take the example of solanaceous crops like tomato, brinjal, and chili, almost 50 to 60% of area is under hybrids. Like in cucurbits like watermelon and cucumber, almost 80 to 90% of area is under hybrids. In the cole crops like cabbage and cauliflower, almost 90 to 95% of area is under hybrids. This has, and also year-end production. And the third factor that is increasing the area and production of vegetable in India is because of supply of high quality planting material through high-tech nurseries. Coming to vegetable nursery and its importance. Vegetable nursery, it's a scientifically managed site. It's a scientifically managed site where seedlings are raised under controlled or semi-controlled environmental condition before transplanting into the main field. What are the importance of vegetable nursery? First one is the seed germination. The seed germination and the seedling growth stage is the most important and critical stage for plant growth. So at this stage, we need to take utmost care. This can be taken care in the nursery by providing optimum growing condition for better development of seedlings. And there is, as we know, India is the second largest producer of vegetables. There is a need of production and supply of quality planting material in the form of seedlings that we can be produced in the by high-tech nursery, because seedling quality and health determines the almost half of the crop yield, means vegetable yield. There are, broadly, there are two types of vegetable nursery. First one is conventional or open field nursery. Second one is high-tech nursery, means modern nursery. Under conventional nursery or open field nursery, conventional nursery means we are preparing the nursery, means the nursery will be there in the open condition. In that, there are three types. First one is flat bed nursery. This nursery we are raising in the areas where we have sufficient irrigation and good drainage facility. Second one is the sunken nursery. We are raising the sunken nursery in the arid and semi-arid region where there is scarcity of water is there, and where there is a need to control where there is a need to protect the seedlings from hot air and dry winds. Third one is the raised bed nursery. This nursery we are commercially means we are following in the vegetable crops in the areas where there is a heavy rainfall and lacking the sufficient, means proper drainage. The dimension or the size of the raised bed will be around. We are raising the beds to a height of 10 to 15 centimeter above the ground level, with a width of 1 to 1.2 meter, with a sufficient length as convenient. Here we can see, means among these three conventional nursery like flat, sunken, and raised bed nursery, we are mostly following the raised bed nursery to raise the seedlings like tomato, brinjal, chili, and onion. Here we can see the raised beds. Here we are raising the seedlings of onion. For raising the seedlings of onion, we are going for the line sowing. Here we can see the line sowing. We are preparing the lines as a distance of 5 centimeter. After preparing these lines, we are going for the sowing. We are going for line sowing of the seedlings. Here we can see the healthy growth of the seedlings. It's almost 10 to 12 days after sowing up the seed. These are the seedlings of onion. Second one is the high-tech nursery. First one is the conventional. Second one is the high-tech nursery. It's a high-tech nursery. It's a specialized, scientifically managed facility. It's a specialized and scientifically managed facility for raising seedlings under the protected structures by using soilless media, plug trays, fertigation, and climatic control. Means high-tech nursery means we are raising the seedlings under the protected structures where we are excluding the soil as a growing media. Here we are using the soilless media. Under the high-tech nursery, there are different components. First one is protected structures. For raising the seedlings and controlling or protecting the seedlings from pests and diseases, we are using the poly houses, net houses, and mist chambers, as well as the load tunnels. Means poly house, shade house, mist chamber, and load tunnels. We are using a protected structure for under high tech nursery. Second one is the growing media. In conventional nursery, we are using the soil as a growing media, but in the high tech nursery, we are using the sterilized soilless substrate like coco peat, vermiculite, perlite, and peat mass. Third important component is the plug trays, means containers or plug trays. These containers or plug trays ensure the uniformity, strong root system, and minimal transplant shock. Fourth important component of high-tech nursery is the climate control. In the high-tech nursery, we are regulating the temperature, light, as well as the humidity. Whatever the seedlings is required, that one only we are giving in the high-tech nursery. Last one is the we are giving the means control of controlled irrigation and nutrition by using mist irrigation. Coming to what are the advantages over the of high-tech nursery over the conventional nursery. First one is the efficient seed use. Whatever seeds we are using in the high-tech nursery are the hybrids. Hybrids means hybrid seeds are the very costly. Each seed cost more. That's what we have to harvest, or we have to get the seedlings from the each seed. Suppose you take the example of tomato. For raising the seedlings in the raised bed system, we require around 100 grams of seeds per acre. But when we are raising the seedlings by using the pro trays, the seed rate may reduce to 70 gram per acre. Here we are saving the 30 gram of seeds by using pro trays. Means suppose you take the example of Arka Rakshak variety, and the seed cost of Arka Rakshak variety is 300 rupees, around 300 rupees per 10 gram of seeds. Here we are saving around 30 gram, means we are saving around 1,000 rupees in the seedling, means in seed stage itself. Second one is the raising of healthy seedlings. In high-tech nursery, we are using the soilless media, means we are using the vermiculite, perlite, coco peat as a growing media. These are the almost sterilized. They are having good water holding capacity, and they are free from soil-borne diseases, like means they are free from inoculum of soil-borne diseases like damping of caused by PTM or PTM. Okay. Next one is there is a high survival rate when we are raising the seedlings in the pro trays. Fourth one is the we can under high-tech nursery we can go for crop scheduling by enabling early crop, off-season crop production, and staggered planting. Coming to overall advantages of high-tech nursery. First, we are discussing what are advantages of high-tech over conventional. Here, we can discuss only what are the overall advantages of high-tech nursery. Here, we are selecting the right media, which is free from inoculum, which is sterilized, which is having a good water holding capacity, and which provides the good aeration that will lead to better seed germination. Second one is we are providing the equal space for each seedling. Means we are showing the single seed per cell. That will give the sufficient space for seedling growth, root development, and also it facilitated better aeration. Third one is there is less seedling mortality because the whatever the media we are using is sterilized, and here we are maintaining the environmental condition where means like temperature, light, and humidity. Fourth one is less loss of expensive seeds. Whatever the seedlings we are raising in the high-tech nurseries are from the hybrid seeds. Here we are showing single seed per cell that will lead to harvesting or getting of seedling from each seed. And last one is the whatever seedlings we are raising in the high-tech nurseries are they almost free from viral diseases because we are raising the seedlings under protected structures like polyhouse and net house. Here we can in detail we can study the what are the components. First one, we know the what are the three important components. First one is the protected structures. Second one is the containers. Third one is the growing media. First one is protected structures. Under high-tech nursery, we are using three protected structures. First one is the polyhouse. The roof of the polyhouse is constructed by using 200 micron UV stabilized polythene sheet, and its sides are covered by 40 mesh insect-proof net house. In the polyhouse, we can raise the healthy seedlings because it protects the seedlings from entry of pest and diseases. Also, we can regulate temperature, whatever the climatic conditions which are required for the seedlings. We can regulate the temperature by adjusting the shade net. We can maintain the humidity, and we can give the irrigation through foggers. Second one, important structure is we are using under high-tech nursery is the net houses. These net houses are constructed by using 40 mesh insect-proof net house. In recent days, along with the polyhouse, net house also nursery raising under net house also gaining very, very important because the cost of raising this net house are very less as compared to polyhouses. Here, these structures are constructed by using granite stone pillars or GI pipe, or low-cost net house can also be prepared constructed by using bamboo to a height of 6 to 8 feet. The roof of these net house are usually covered by shade nets or insect-proof net house. This can avoid the entry of vectors which carries the viral diseases. Here we can see the structure of net house. The top the roof is constructed or covered by using by shade net, and the sides are covered by insect-proof net house insect-proof net. The third important structures we are using for raising these seedlings are under high-tech nursery is the polytunnels. These are constructed by using galvanized steel hoops or plastic pipes. These polytunnels are covered by, as similar to polyhouse, they are covered by polythene sheet of 200 micron. These structures are usually used to raise the seedlings under off-season. The second important component of the high-tech nurseries are containers. The most commonly used container in the high-tech nursery is the seedlings trays. These are also called as pro trays or flat trays or plug trays. These pro trays are made up of polypropylene plastic, polypropylene. The high quality seedling pro tray can be used up to 6 times to grow these seedlings. In pro trays, there
The slides are not visible, sir. Maragal sir, are you there? Hello, sir. Maragal sir.
Hello. Hello.
Yes, ma'am. Yes, sir.
Found that my nurse is so with her. यहाँ से वहाँ से ड्राइव बात करना
Yes, sir. Continue, please.
It's coming now, sir. Please slideshow. Yeah, hello.
Yeah, it's okay.
Yeah,
It's okay, sir. Please continue.
yes, sir.
Yeah, fine. Sir, your voice is not audible. Are you speaking? No, sir. Your voice is not audible. Are you speaking? Kindly check again. Your slides are not moving also.
Hello, am I audible?
Yes, sir. Audible. Audible. Continue, please.
Okay, sir. Sure. Okay, now it's slides also visible, sir. The second important component of high-tech nursery is the containers. In that, we are using the seedling trays. We are also called it as fruit trays, flat trays, or plug trays. These are made up of polypropylene. These trays we can use up to 6 times to grow these seedlings. These seedling trays, the equip space cells of this seedling space facilitate even growth of the seedlings. The holes at the bottom of the each cell can facilitate proper drainage. For raising the vegetable seedlings in the crops like tomato, capsicum, cabbage, cauliflower, and chili, we are using the pro trays which are having 98 cells. The size of these trays will be around 54 centimeter in length and 27 centimeter in the width. Here we can see the 98 cell pro tray we are commonly using in raising the seedlings, vegetable seedlings. Coming to what are the advantages of container? What are the advantages of containers seedling over the seedling which are raised in the raised beds, that is in conventional nursery? These seedlings which are raised in container seedling, they have reduces transplanting shock, because in container seedlings we are transplanting the seedlings along with the root ball. There is no any damage to the roots, so there will be better transplant establishment in the field. The third important component of high-tech nursery is the media. The ideal characteristics of the media which are using in the high-tech nursery should be biologically inert. It should not contain any growth inhibitors that can inhibit the seed germination and seedling growth. The growing media should have uniform in structure. It should have better porosity of 85%, and it should have better water holding capacity and it should have pH of 5.5 to 6.5 with a good carbon exchange capacity. There are different types of growing media which we are using in the nursery. First one is organic media. In that we are using the stagnant mass, peat humus, and other organic waste like sawdust, pine bark, pine chips, etc. Even also paddy husk also we are using as a growing media in nursery. The most important and most commonly used growing media in high-tech nursery is the coco peat. This is a phosphorus which is a decomposer acquired dust from the coconut industry. This coco peat is most popular because of it is having high water holding capacity and it's porous in nature. To fill the 100 trays of 90 to fill 100 trays which are having 98 cells, we require around 100 kg of coco peat. To fill the one pro tray, we need around 1 to 1.55 kg of coco peat. After filling the coco peat, we have to make a depression of 5 mm deep to place the seeds. After, is it audible, sir? Hello.
It is audible,
Yes, it's
sir.
audible. Please continue.
Audible,
Okay.
sir. Please kindly raise
Audible.
Thank you. Okay, thank you, sir. After sowing the seeds, again you have to go for covering of the seeds by using the coco peat. In coco peat media, one person can sow the 200 trays of seeds. One person can fill the 200 trays, which can accumulate around 20,000 seeds per day. Next one is the inorganic media. Here, under inorganic media, there will be vermiculite will be there, perlite will be there. They are having good water holding capacity. They are neutral in nature, but they are because of their high cost, these vermiculite and perlite we are not commonly using in the high tech. These are also they are good in raising the seedlings. Next one, after knowing the components of high-tech nursery, next one is the methods to raise the seedlings. First one is the wash the trays, means to wash the fruit trays by using fungicides like carbon dioxide, 3 grams per liter. After washing the tray, we have to go for filling of the coat trays. After filling coat trays by cockpit, after filling the coat trays, we have to make a small depressions by using fingers or devices like dibblers. After making the depressions, we have to go for sowing up the seeds. Here we have to sow single seed per cell. After sowing the seeds, again we have to cover with the coco peat and we have to give the light irrigation. After giving the light irrigation, we have to stake each fruit tray over. We have to make a stake of 5 to 6 fruit trays and we have to cover with the polythene sheet. To maintain the
fun words today?
sufficient
Let's
humidity
know
and
the
to
first
maintain the
part.
temperature. It will take
Water. Water. Water.
चलो यार वो बे खा So please share your presentation again. Participant, please mute yourself.
It's time to eat.
Hello. So are you there?
It's connecting again, madam, due to some net connectivity issue. He's facing problems, and he's working on this to fix it.
Okay.
hello. Am I audible now?
Audible and
Slides
yeah.
also I think visible, sir.
Continue, sir.
Yes, sir. For seed germination, usually it will take 3 to 7 days. Depends upon the crop. For better germination, there will we have to keep in mind that there will be 3 factors that can regulate the seed germination. First one is the temperature. For better germination, you have to maintain the temperature of around 25 to 28 degrees Celsius for better seed germination. Second one is the relative humidity. We have to maintain 70 to 80% of relative humidity, and you have to properly maintain the soil media moisture by giving the light irrigation at the time of seed sowing. Suppose you take the example of chili, when we maintain the temperature of 25 to 28 degrees Celsius, it's ideal for seed germination. It will take around 8 days. But when we reduce the when the temperature is less, suppose at the 20 degrees Celsius, it will take 12 days. At 15 degrees Celsius, it will take 20 days. It says that the temperature is a very crucial factor which can decide the seed germination. Here we can see these are the research findings. Here we can see in different crops, like when you increase the temperature, there will be a reduction in the seed germination days. When you increase the temperature, there will be reduction in the days for seed germination. These are seedlings of chili, watermelon. Okay. Once they receive the seed germination, we have to place these trays on the benches where overhead irrigation is there. Suppose benches are there, not there. In the protected structures, you have to make the raised beds to a height of 10 to 15 centimeter. After that, we have to cover with the mulching sheet. After that, we need to place the germinated fruit trays. After seed germination, we have to properly irrigate the properly irrigate the seedlings by using fine sprinklers or hose can. We should always keep the media moist but not completely wet. Complete wetting of the media may leads to diseases like damping off. For better development or healthy, to get the healthy seedlings, we have to go for spraying of the water soluble fertilizers like 19L at a concentration of 2 or 3 grams per liter at 2 to 4 leaf stage. For better in nursery stage, damping up is the major disease caused by the PTM. To control this one, we have to go for drenching of COC 3 grams per liter, or we have to go for carbendazim 1 to 2 grams per liter. In the seedling stage, infestation of sucking pests like aphids and white flies is the major problem. To control that, you have to go for spraying of or drenching of imidacloprid 0.3 to 0.5 ml per liter. Once the seedlings are ready, 1 week before transplanting of the seedlings, we have to go for proper hardening of the seedlings to acclimatize the seedlings in the male field. This hardening can be accomplished by increasing light intensity, exposing this transplant to full sunlight, reducing the irrigation and watering. The last stage of this nursery is the marketing of the seedlings. Here you can see the cost of each seedlings. Suppose you take the example of chili, we can sell the seedlings at the cost of 80 paisa per seedling, means it will cost around 800 per thousand seedlings in chili, 1,000 rupees in tomato, around 2,000 to 2,500 in watermelon, around 500 to 600 rupees in cabbage, and around 1,000 rupees in cauliflower at the profit margin of 30 to 40%. This cost includes the profit margin of 30 to 40%. Once the seedlings are ready, we have to transplant the seedlings by staking the fruit trays to the main field, or we can sell it to the customers who have indented these seedlings. Before concluding this seminar, I want to say one success story of my senior. His name is Mr. Shankar Naganav. He is from Karnataka. His qualification is BSc Horticulture. Immediately after completing his degree in horticulture, he has initiated one small nursery, that is Kalpataru Nursery. After getting the success in his vegetable nursery, means first he has started the hello.
Yes, sir. Yes, sir. Continue. No issue.
In initial day, he has started with the vegetable and fruit crop nursery. In that, he started to raise the seedlings of vegetable crops like tomato, chili, capsicum, watermelon, and the fruit crops like fruits like papaya. And he has started the production of tissue culture banana. After getting the success in the vegetable nursery, he has started to raise the nursery to raise the seedlings of sugarcane by using by single node method. Here you can see the in the 2014 means 2 years of 2 years of his degree. He has started vegetable nursery in the name of Kalpataru High Tech Nursery with an area of 2 acres. In that he is producing vegetable seedlings, banana, papaya, and turmeric, and he's supplying his seedlings to almost all the parts of Karnataka, throughout the Karnataka and the part of Maharashtra. This is the view of his nursery where he is raising vegetable seedlings as well as tissue culture banana. After getting success in the vegetable nursery by his income, by his earning, he has initiated one more nursery, that is to raise the seedlings of sugarcane by using single node method in an area of 5.5 acres. Here we can see his business. Annually, he is raising the seedlings of 10 lakh in chili, 15 lakh seedlings in tomato, around 5 lakh seedlings in watermelon, around 50 lakh seedlings in cabbage, 10 lakh in cauliflower, 1 to 2 lakh in capsicum. He is also raising the seedlings of flower crop like marigold. With he is annually producing around 2 to 3 lakh seedlings of marigold. He is selling the tissue culture G9 banana and around 10 lakh, and he is selling he is raising this around 25 lakh seedlings of sugar cane. Annually in and around he is selling or he is raising around 1 crore seedlings of different vegetable crops as well as sugarcane. He is supplying throughout the Karnataka and in the part of Maharashtra with a profit margin of 30 to 40%. The annual turnover of this person is around 3 crores in a year. Here we can see the seedlings which are raised through single node method, which are raising in the 98 celled fruit tray. He has also initiated the one horticulture farm with an area of 10 acres, where he is raising the 1 acre of banana, 1 acre of vegetable product cultivation, 2 acres of banana, 3 acres of sugarcane, and 4 acres of other plantation crops. Under NHB project, he has constructed one polyhouse in an area of 1 acre, means 44,000 meters square. There he initially has raised the capsicum. After that, he is using entire polyhouse for raising the vegetable nursery. The project cost was around 40 lakh, which was funded by NHB. Concluding to this presentation, the rapid expansion of vegetable production has created a significant demand for uniform, healthy, and disease-free seedlings. The high-tech nursery can offer scientifically managed, low-risk, and high-return opportunity for youth-led agriculture entrepreneurship. This high-tech nursery ensures year-round income generation, employment creation, and contribution to sustainable vegetable production system. At the end, I can share high-tech nursery is a promising entrepreneurship model for next generation agriculture entrepreneurship. Thank you. Thank you, Anand.
Okay, thank you, Dr. Maraga, for your beautiful presentation. Now the session is open for questionnaire. Anybody, any of our participants who want to ask any questions, kindly ask. Any participants, please?
Thank you. Participants, any questions, please go ahead. Participants, if you have any questions, please ask. The session is open for discussion.
Sir, good morning, sir.